Mandy. Congratulations, miss. Okay. You got your notes over there? All right. All right, here we go, guys. You guys ready? We're going to talk BC after this. Don't worry. All right, guys. Focus. So this is a pretty important topic. You're going to see right now why. So differential equations. There is a whole course dedicated to this after Cal 2, after multivariable calculus. At the university, it's Cal 1, Cal 2, Cal 3, if they offer a 3-sequence course. And then differential equations, DFQ. There's a whole course dedicated to this. You already know what a differential equation is for the most part. We've been doing the simple ones. We've been doing a first order equation, which is just one derivative, first derivative. If your university does not offer a 3 calculus course, it's going to be single variable cal, multivariable cal, and then differential equations. So there's a whole course dedicated to this. So that's how important it is. So here we go. These are the differential equations that we have been doing. And for these, they're pretty straightforward. You already know how to solve for that. So what does it say? Find all functions y that satisfy dy dx equals secant squared plus 2x plus 5. So let's see if we can do this together really quick. So I want a function y. So I'm going to write y equals. So all I'm doing, because this is my derivative, all I'm doing is taking a antiderivative. What is the antiderivative of secant squared? 10x. What's the antiderivative of 2x? X squared. Yeah, 2x squared divided by 2. The 2's cancel out. What's antiderivative of 5? 5x. And because plus, perfect. Plus c. Don't ever forget that. Plus c. And this, you already have experience with that. You've been doing that over and over again. So this is just like a warm-up. Are we cool with that? All right, so here's another warm-up. But notice this one, it says, find a particular solution to the equation dy dx equals blah, whose graph passes through the point 1, 0. That 1 is an x value. That 0 is a y value. So now I don't want a plus c. I want like the actual constant. Does that make sense? You're still going to put plus c when you're solving. So here we go. I'm going to write y equals, because all I'm doing is antiderivative, right? What's the antiderivative of e to the x? E to the x minus, what's the antiderivative of 6x squared? 3x to the, wait, not 3, 2. No, it's okay. 2x to the third. And in case you're wondering, like, Travis, how'd you do that? Add 1, divide by that number. And then we're still not done. Plus c. Are we okay? All right. Now from there, I need to solve for what c is. I take that point, 1, 0, and I plug it in. That 1's an x, that 0 is a y. Does that make sense to you guys? 0 equals e to the 1 minus 2 times 1 to the third plus c. So that means I have, let's see, 0. And you don't have to do it repetitive. I'm just showing all the details here. And I'm going to move these two to the left here. So I'm going to say that c equals 2 minus e. Do you guys see that? So my equation, and I'm going to write, so my specific equation or particular solution is y equals e to the x minus 2x cubed plus 2 minus e. If you want to group the 2 and the e together with parentheses, you can if you want, but you don't have to. They're constants. What's up? When I move e minus 2, oops, my bad. That's no, wait, no, that's 2 plus 2 minus e. Okay, what? Yeah, when I move to the other side. I'm using the reflective property from geometry. I guess I should have done this first. I should have done 2 minus e equals c, and then I can just rewrite it as c equals 2 minus e. So sorry, guys. What's up? Find the exact equation. Because they wrote particular solution, we can actually leave it as in e to the x plus 2x cubed plus y equals negative e if I wanted to. But usually they tell you y equals f of x, or find like it in terms of something. And you'll see right now in a little bit. How do we feel, guys? Do we feel okay? Okay. Do you guys want to read this really quick to yourselves, really fast? Okay, all that means is that you can group the x's with the x's, the y's with the y's. Now, I probably should have put in there for good notes, not all differential equations are separable. So let me write that in here. Not all diff EQ are separable. That's how you abbreviate differential equations, diff EQ. But the ones that I show here, because we're rookies, these are. Eventually, we're going to get you to where we're going to ask ourselves, is this separable? Can I? Blah, blah, blah. But right now, we're just practicing. Cool? So check it out. The very first one, example 3. Solve for y if dy dx equals xy squared and y equals 1 and x equals 1. So they want an equation. They want y equals something. Notice, how is this different than the last one? I can't just do an antiderivative because this has a y in it. That makes sense? Like this was take the derivative with respect to x. Well, now there's x's and y's. So yeah, it's like implicit kind of. So we got to separate stuff. We got to group them all together. So here we go. Here's how we're going to do it. First, we just do basic algebra. Laws of exponents, x squared, y squared. Can we do that? Okay. Next, I'm going to group the y's with the y's, the x's with the x's. Chavez, what does that mean? That means this. I'm going to write dy over y squared. See, divide by y squared equals, and I'm going to multiply by dx. So times dx times dx, so I'm going to have x squared dx. How do we feel? So cautious, guys, a word of advice. Do not put the dx in the front. I know what you mean, like you're saying dx times x squared, but do not put it in the front because how are we going to get rid of the dx and the dy? We're going to integrate. And remember when you draw the integral symbol, the elongated s, the dx means like this is the end of your integrand. Cool? Okay, so I'm going to rewrite this. Here's how I'm going to rewrite it. 1 over y squared dy equals x squared dx. So just like I said right now, what am I going to put in front of this? An integrand symbol. Why am I doing that? So I can get rid of the dy and dx. Does that make sense to everyone? All right, so you're one more step of calculus, and it's not really calculus now. Integral y to the negative 2 dy. I'm just making it simple. Making it where I can take an antiderivative. Does that make sense? All right, what's antiderivative of y to the negative 2? Not everyone at the same time. Yeah, y to the negative 1 over negative 1. So can I put the negative in the front? And I could put plus c. Okay, so drop your pencils down. Don't write this part down because I want you guys to listen. I could put plus c if I wanted to. I'm going to call that c1 equals, and don't write down, don't worry, I'll tell you what to write down in a little bit. What's the antiderivative of x squared? X cubed over 3, and then I could put plus c2, or c2 here. But when I do this, whenever I subtract c1 and I subtract c1, isn't c2 minus c1 still a constant? Okay, so the common practice is to not write c on the left-hand side with the y's, and to just write 1c with the x's. Does that make sense to you guys? Okay, so now you can write. You can put in their common practice, just put one constant. Oh, ask BC, what's up? So Chavez, how are we going to find the constant? We're going to let the situation tell us what that constant is. Does that make sense? We're going to let this situation, you see how it says x equals 1, y equals 1? That situation will tell us what the constant is. Cool? All right, this looks like a good place to type in my 1, 1. That is my quarter pair 1, 1, right? So I'm going to rewrite it, guys. Negative 1 over y equals x cubed over 3 plus c. This looks like a good location to solve for c. So I'm going to put insert x equals 1, y equals 1 for good notes. So here we go. 1 divided by, well, negative 1 divided by 1 is going to be negative 1 equals 1 to the third power is 1. So I'm going to have 1 over 3 plus c like that, right? Okay. Now how do I get c by itself? Subtract 1/3. So I'm going to write an arrow. I'm going to put c equals, what is negative 1 minus 1/3? Perfect. So negative 4/3. I wrote an arrow because I'm running out of space here. So now that I know that C is negative 4/3, that's what I'm going to substitute for my C at this step. Does that make sense, guys? So I'm going to write it like this. I guess I could write it the one below. Negative 1 over y equals, yeah, I'm going to do that one. X cubed over 3 minus 4 over 3. Oh, look, they're being nice to me. And I should have written smaller. I see that my denominators are 3. You're done with calculus. Everything else is algebra. You're trying to get this in terms of y equals. Does that make sense? Yeah, we're not doing calculus anymore, guys. We're just doing algebra. So I'm going to write negative 1 over y equals x cubed minus 4 over 3. Do you guys know a hack of what you would... Yeah, see how... Okay, so I'm going to slow down because this is probably some algebra stuff that, you know, we haven't had algebra in the last 2 years, like hardcore. This is a fraction. This is a fraction. So side note, if I have A over B equals C over D, isn't that the same as saying B over A equals D over C? Yeah, it's the same. As long as you keep everything together like that. Does that make sense? So this is negative y over 1 equals 3 over x cubed minus 4. Does that make sense to you guys? Okay, that's just algebra, guys. So that's stuff that we should have done like a long time ago. If you didn't, it's okay. You know, blame it on the situation we're in. Are we cool? All right, we just got to do one little thing. So I'm going to write it on top of here. I ran out of space. I'm sorry, guys. So I'm going to write it negative y over 1. Well, you know what? I'm going to remove that 1 there. Equals 3 over x cubed minus 4. All I got to do is, I want a positive y. So all I got to do is what? Yeah, either divide by negative 1 or multiply by negative 1. It doesn't matter. Y equals, negative in the front, 3 over x cubed minus 4. And I had a professor who would always, all the time, tell me to put a minus, my minus there. Because I had a habit of doing this. I would just put it here. It doesn't matter, guys. You can put the negative with the 3 there, but because he told me, I'll go ahead and do that. How do we feel? That's it. We're done. That's what they wanted, right? So you can see there's a lot of algebra. There's not much calculus. The only calculus is doing the antiderivative. The rest is algebra. Okay. So you can tell what's going to happen, guys. Tomorrow we're going to do even more algebra with logs and exponentials. So you guys remember, right? Like when we did the dy. Okay, yeah, it's going to be fun. It's going to be fun. Now, if you're weak with logs and exponentials, then you might not have a good time initially, but you see that it's not going to be that bad. All right. Use integration to find the general solution to these equations. So now we're just practicing. I don't see any y's over here. So in my opinion, I would just do this. dy dx equals 4x squared minus 4x. And I'm just going to do an antiderivative of that. So I don't need to separate my variables. This is coming from UH, guys. So you can already tell what's going to be the next quiz. So I'm going to write y equals, what am I going to write? 4x cubed over 3 minus, which is, and then am I done? Plus c. Let's look for that answer. Is that in there? It's the first one. Does everyone see how we did it? Okay. Let's look at the next one. Does the next one have y's in it, x and y's? We're going to have to separate our variables. Cool? Okay. So, I want the y's with the y's. You cannot separate that 5. That 5 is grouped with that y, guys. Because isn't the y plus 5 in the denominator? So, how do I get rid of the y plus 5? Multiply. When I do that, you're going to have y plus 5 dy equals x minus 3. If you want to put this in parentheses, dx. Now, I will give you a heads up. Personally, I don't like it, but textbooks have done it. I do not like when they remove the parentheses and they do that. I don't like it because it looks like it's, right, you see it, but it's understood. Don't get mad. It's understood in the math world. We understand it that it's that. times dy, that it's this times dx. Cool or not cool? Okay. Is everyone okay so far? Nothing crazy has happened, right? All right, what's antiderivative of y? Y squared over 2. Yeah, that's it. What's antiderivative of 5 with respect to y? 5y. Chavez, why? Because this is my integral with the y's on it. Are we okay? Don't write a plus c on this side. Write the plus c with the x's. What's the antiderivative of x? Minus what's antiderivative of 3? What am I going to write? Plus c. Before you continue, I'll wait for everyone to catch up. Before you continue, let's be smart, guys. You're done with calculus. You're done. Everything else is algebra now. Notice your answer choices. Do any of them have fractions? No. What's up? Did I mess up? Oh, sorry. So I see a 2 in the bottom. I can multiply the whole shebang, all of it, by 2, and that will cancel my denominator in the bottom. Does that make sense to everyone? All right, so let me see. I'm going to have y squared plus 10y equals x squared minus 6x. Oh, here's a good question. Plus, do I write 2c or do I write c? C. Perfect. Why am I writing c? It's still a constant. Any constant times 2 is it still a constant? It's still a constant. So you're just going to write c. Do not write 2c. Do we understand that? Okay, we're done, guys. Now you just got to make it look like one of these. Notice that all of them have equal c. So that means move the x squared to the left. Move the negative 6x to the left. So my equation is going to be, is that a negative x squared? Negative x squared plus y squared. And then what do they put next? That's 6x plus 6x plus 10y. That's a 10. Equals c. Let's look for that. Is that in there? Which one is it? C. All right. How do we feel? All right. Let's keep going. Let's keep going. We're getting more experience. This is good. So again, they want the same thing, guys. This equation's here. It's in terms of x and y. I'm going to separate my variables. You must separate. Please show that. So what does that mean? It just means group the y's with the y's, group the x's with the x's. Cool? So I'm going to go dy over, what did I put in the bottom here? Secant y, perfect. Secant y equals, and what did I put here on the right-hand side? Yeah, you can write dx over x minus 3. I'm going to write it as 1 over x minus 3 squared times dx. You can write dx over x minus 3 squared, but I'm going to just writing it like that for simplicity. How do we feel? Okay. Okay, so here's what I see. I see the left-hand side is going to be pretty simple. The right side can be complicated. It depends. All right. So what's, I'm not going to integrate right now. What's 1 over secant? Bless you. Cosine, yeah. Yeah, be confident, guys. You're good. So can I write the left-hand side as cosine y dy? Yes. Now, side note, you don't have to. If you're confident, I think you're fine. But if you feel that you're not confident, you can do u sub with the right-hand side. Like, oh, child, I don't know if I can integrate that. Because, right, we want to integrate that. So integral cosine y dy equals, if you're not confident, you can do u sub. What would I make u? X minus 3, perfect. What is du? 1 dx. There's 1 du. There's a dx there. I can just replace it. So this is the same thing as 1 over u squared du. Does that make sense to you guys? And if you rewrite it again, u to the negative 2 du. How do we feel? Yeah. So, well, I would write that on the side. I would leave this as... Personally, I would leave this as this, but I'm confident. If you're not confident, just put it on the side somewhere. Okay, so here we go. What's antiderivative of cosine y dy? What's antiderivative of cosine? Sine. Positive or negative? Yeah, positive. Equals, what's antiderivative of u to the negative 2? U to the negative 1 divided by negative 1. So can I say negative 1 over u, and isn't u x minus 3? Can I say that? Plus, don't forget, plus what? Plus c. Let's look for that. Is that in here? Yes. How do we feel? All right, BC, if you want to get started with the question in advance, the next one, or I think the next two are going to be too simple for you guys. So if you guys want to get started with the free response, you can, and then we'll check it right now. All right, question 7. If you want to continue, that's fine. Continue with them. Ready for you guys? We're still with this. We're just practicing, guys. Ready? I have x's and y's. I got to separate it. Here's how you're going to see it in Delta Math today. So I'm going to, what do I do with that 3y there? Perfect. So I'm going to write 3y dy equals x squared plus 1. If you want to put parentheses, I would. Dx. You don't have to if you don't want to. Then I'm going to, well, I'm not putting plus c yet. I have to what? Put the integral symbol. So what's the antiderivative of 3y? Perfect. Equals, what's the antiderivative of x squared? Plus, what's the antiderivative of 1? X plus c. It tells me this question said that I want a particular solution, so that means y equals something. They tell me this. So that means when x is 3, the y value is negative 2. Notice they word the word initial. Usually initial is like, well, it doesn't matter. Okay, so here we go. Let's plug in. Cool. So we're going to go, should I plug in now? Yeah, that's fine. 3 times negative 2 squared divided by 2 equals 3 cubed over 3 plus 3 plus c. I don't think we need a calculator, but let's see. Negative 2 squared is 4. Positive 4. 4 times 3 is 12. 12 divided by 2 is, so 6 equals 3 cubed, or I guess it's going to be 3 squared, so 9. Right? 3 to the third power is 27 divided by 3, 9. 9 plus 3 plus c. Move the 9 and 3 to the other side, or I guess 9 plus 3 first is what, 12? 6 minus 12. So c equals positive or negative? Negative, right? So I'm going to come back here and I'm going to plug it in. So I had 3y squared over 2 equals x cubed over 3 plus x minus 6. All right. Next, you're trying to get y by itself, correct? So I'm going to multiply the whole shebang by the reciprocal of 3 over 2 times y. So I can get rid of the 3/2. So I'm going to multiply by 2/3. Does that make sense to everyone? So when I do that, I'm going to have y squared equals, let's see, 2x cubed over 9 plus 2/3 x minus, 3 goes into 6 twice, 2 times 2, 4. And check my math, because sometimes I make mistakes. We're just doing algebra. We're not doing calculus anymore. And then one last step. How do I get rid of that square there? Square root. When you take square root, don't forget the plus minus. Y equals plus minus square root of all this shebang. Now it can't be, right now I have 2 equations, the plus and the minus. I need to only have one. Is it the positive square root or is it the negative square root? Why is it the negative? Yeah, when I plug in a 3, you're supposed to get a negative 2 as an output. Does that make sense? When I plug in an x value of 3, I need to have a negative 2 as an output. Yeah, don't worry, we're going to explain it. We're going to explain it. Check. What am I checking? If I plug in a 3 into my x value, do I get an output of negative 2? So let's see. 3 cubed is 27. I see that 9 down here. 9 goes into 27 3 times. 3 times 2 is 6. So this gives me a 6. And then I'm plugging in a 3, right? So the 3's cancel out. So 6 plus 2. 6 plus 2 is 6, 7, 8. Is 8. 8 minus 4 is 4. What's the square root of 4? 2. And do I have a negative on the outside to make a negative? There it is. How do you feel? Parker, did we get that?
Once you explain it, yeah, but it's just like,
Yeah, a lot of students mess up with the plus minus. I'll show you for your response that a lot of students, and I think I graded that one, where they just forgot the negative and I mean, luckily for us, usually this equation is worth just 1 point, usually. But the process is worth like 5. Someone had a question? I heard someone say Chavez. Okay, let's go to the next one, guys. Example 8. Given the differential equation, dy dx equals x squared over 2y squared, find a particular solution, y equals f of x with the initial condition, f of 3 equals negative 3. All right, I'm going to write smaller just in case I take up more space well, it doesn't matter. All right, here we go. First thing, move the x's with the x's, move the y's with the y's. So we're going to have 2y squared equals x squared dx. Can we at least do that? If you do that, that's probably a point. Next, we're going to what? Integrate. Put that integral symbol. What's the antiderivative of 2y squared? Yeah, 2y to the 3, or 2/3. You can write 2/3. I'm just trying to... Yes. Oh, man. That's why you guys were looking at me weird. You must put the dy because it was there to begin with. Yeah, I'm sorry. Yeah, you got to tell me. I make mistakes, guys. That dy must be there. If it's not there, you're not going to get the point. That dy must be there. So 2/3 y cubed equals, I think we did that correct, equals, what's antiderivative of x squared? X cubed over 3. Did we do that correct? And then I put plus what? Plus c. I think this is a good place to plug in my point. The point they give me is 3, negative 3. I would be careful. You can do it that way too. But I would be careful because if you solve for y, it's going to be a cubic. And I see like something plus c over like 2 or whatever. Yeah, because that's a 2 there. And then that looks like, oh, now let's plug in the 3 and the negative 3. And now you're going to have to get c by itself again. You know what I mean? Like the whole point is to get c by itself. And right now, c is by itself. I just got to, does that make sense? But yes, you should still get the same answer. All right, here we go. I'm going to plug in that 3, negative 3. If you want to make life easier, maybe multiply by 3, and then maybe you could do it in one more step, and then, you know what I mean? But it doesn't matter. I already said I want to do it here. I'm already committed, so I'm going to do it right here, guys. 2 times 3, is it a positive or negative? Negative, right? Negative 3 to the third divided by 3 equals, make sure we don't have any mistakes here, 3 to the third over 3 plus c. All right. Negative 3 to the third is negative 27, but then I have a 3 in the bottom, so that's negative 9. Negative 9 times 2. Okay. And then this is going to be 3 to the third again, 27 divided by 3. That's going to be a 9, correct? Plus c. So that means c equals, so negative 18 minus 9, is that a negative 27? Okay, so I'm going to plug that in right there. So I have 2/3 y cubed equals x over 3. I said 2/3. I could write 1/3 x cubed, but that's fine. Minus 27. So I'm going to, what am I trying to solve for? For y? Okay. Multiply by what? 3 halves, the reciprocal. So times 3 halves, and then times 3 halves. And there it is, my colored pencil, so you could see the notes here. Y cubed equals, let's see, the 3's cancel out. So I have x cubed over 2 minus 27 times 3, 30, 60, 90, 3, 6, 81. 81 over 2. Okay, I'm going to, yeah, that feels correct to me. I'm going to write it with the 2 in the bottom, guys. I should have just done this. That's fine. And then all I'm going to do now is just take the, how do I get rid of that cube there? Cube root. When you do cube root, make sure you put that 3 there, or else it's a square root. So y equals the cube root of x cubed minus 81 divided by 2. And I'm going to check it. No, that's only for square root. Cube root does not have plus minus. Yes. Even powers, yeah. Even root. All right, check it. Don't just say I'm done. We're good. We got it. Check it, guys. So what was my x value here? 3. If you plug in a 3, do you get a negative 27 inside that cube root? Because the cube root of negative 27 is negative 3, right? So let's see if we get that. 3 cubed, that's 27, minus 81, negative 54, divided by, negative 27. There it is. We got it right, guys. 27 minus 81, it's a negative 54. And then half of 54 is 27, so negative 27. The cube root of negative 27, negative 3. So it works. Cool or not cool? Okay, here we go. Ready? Go to the next page. Our first free response. Well, we've done many free responses, but. All right, I want everyone to have the experience. Are you guys ready? Do you guys want to see if you can figure out letter A? Letter A is not okay, in case you're wondering, this is the part that we just learned today. Learned today. This you already know. This you already know. And I know you haven't even read the question yet, so you're like, Do you guys want 2 minutes to read the story and then give you another 2 minutes to see if you can figure out letter A? Just focus on letter A. So take 4 minutes, focus on letter A. Don't worry, YouTube, I'll fast forward this. Yeah, go for it.
Yeah, we're required. Yeah, because if we left with 6 periods, they here right now, right?
There, miss. What's up, miss?
You have Delta on, right?
All right, guys. Did you guys read the situation of what's going on? All right. So hopefully everyone read this. YouTube, I hope you read it. If you didn't, pause it and read it real quick. They don't have to give you the volume formula. They did. They were nice. And they told us DHDT, how DHDT behaves. They computed it for us. That's fine. Are we okay? They want to know, let's see what letter A says. Find the rate of change of volume of the water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Bless you. What does that mean, rate of change of volume? What do they want? Perfect. If you understand that that means dVdt, you're winning. They give you the volume formula. You don't have to do product rule if you see it. You can if you want. What's a constant? Let's talk about this cylinder here. The radius is a constant. It is always 1. You can do product rule if you want. And then when you plug in your drdt, dr dt is always going to be 0. And so that's going to go away anyways. I would not do product rule. I would hope that you know that your r is always 1. So your dr dt is 0. Sorry. I didn't mean to write that down. Does that make sense to you guys? All right. So here we go. I'm going to write volume. Pi r squared h. And then tell me what is a constant on the pi r squared h. Yeah, perfect. The pi r squared is a constant. So look how easy it is. This is probably a point. I haven't looked at the rubric just yet. All I'm going to do is take a derivative of this. With respect to what? So dv dt is equal to pi r squared, and then what's the derivative of h with respect to time? There it is. You got it. That's my volume formula. What's up? Why do I what? Oh, yeah, I'm gonna substitute that right now. What would it be 0? The derivative of pi r squared is 0, but I'm not taking the derivative of pi r squared. I'm taking the derivative of pi r squared h. It's like saying, so don't write this down, just listen. It's like saying, what's the derivative of 5x? You're not gonna tell me 0, because 5 is a constant. You just tell me 5. You can do product rule with 5x if you wanted to. Y prime equals first, 5 times derivative of the second, 1, plus second x times derivative of the 5, 0. Oh, look, you just get 5, because that goes away. Do you see that or no? Yeah, so, and I know I'm using a very basic sample, a very simple one. You know what? Maybe I should have used a trig one because it's better. It's like saying y equals 3 sine x. You know what I mean? Like, okay, what's up, Parker?
The R would become 2R.
You can. If you were to do product rule and you want, I mean, the r is not changing. The r is constant.
Oh, yes, okay.
But if you did it, 2r dr dt, and what's dr dt? 0. So if you were to plug in at the very end, you're still going to get your same answer. But the best way on this one is to do it like this, because r is a constant. Yeah. All right. Now let's find out what dv dt is, guys. So I'm going to write dv dt is equal to pi times, what's my radius? 1 squared times dh dt. So I'm going to write times negative 1/10, and then the square root of, what's my h? 4. So here it is. I'm going to get pi times 1 times negative 2/10. So all that reduces to negative pi over 5. And I need units. Negative pi over 5 cubic feet. Cubic feet per second. Units, it tells you right here, indicate units of measure. Are we okay with that, guys? So how do you feel? You think you can do that? Well, with experience, you will, right? Okay. Do you guys want to see if you guys can tackle letter B? So take a 2-minute head start. It's a play on words, guys. So think about it carefully. Yeah, that's a 3. Cubic feet. Let me make it better. What do you guys think? What do they want? It says when the height of the water is 3 feet, I'm going to underline this, is, and I'm going to underline, well, I'm going to put it in a bracket, is the rate of change of the height of the water with respect to time. I'm going to put that in bracket. Put all that in brackets. So, yeah, perfect. So the rate of change of height of the water with respect to time. What is that? You said it right now. What is that? That is dHdt. So let's reread it again. Delete all that. Well, don't delete it, but pretend that it's not there, the bracket, and replace it with dHdt. So when the height of the water is 3 feet, is dHdt increasing or decreasing? So how do I figure out if dHdt is increasing or decreasing? Take a derivative of dHdt. So it's going to be the second derivative. And if the second derivative is positive, then dHdt is. And if the second derivative is negative, then dHdt is. There it is. Do you guys see that? Perfect. So here we go. Ready? I'm going to first write what dHdt is. They gave it to me. What was dHdt? Okay, so 1/10 square root of h. I'm going to rewrite it. Negative 1/10 h to the half. Here I am. I'm about to take the second derivative. d2h over dt squared. That means second derivative is equal to, so what is negative 1/10 times a half? Negative 1/20th, and then I'm going to subtract 1 from the half, so h to the negative half. And did I take this derivative with respect to h or respect to t? With respect to t, so right next to it I got to write what? Perfect. That is my second derivative right there. So let's see if I can rewrite it pretty now. D squared h over dt squared equals negative 1 over 20 square root of h times, what was dHdt? Negative 1/10 square root of h. Ooh, I see a lot of stuff canceling. Let's evaluate. You guys ready? They did tell us that the water is 3 feet, but I don't even think I'm going to need it. Do the square root of h's cancel out? They do, guys. I don't even need it. So what is negative 1/20th times negative 1/10? It's going to be a positive 1 over, what's 20 times 10? 200. Is that a positive number? Yeah. So I'm going to write right here what's happening. I'm going to write it. I'm going to use their language. I'm going to write the rate of change. I think you would still be okay if you write dHdt, but I'm going to write there. I'm going to use their language. The rate of change of the height of the water with respect to time is what? Yeah, I heard, be confident. Is what? Is increasing. Why? What's positive? The second derivative, so make sure you say that. With respect to time is increasing since the second derivative, I'm going to write it like this, guys, with this symbol. Since d2h over dt squared is positive at, give me a specific time, at, well, not time, when the height is what? At h equals 3. Perfect. Feet. That's full credit. The rate of change of the height of the water with respect to time is increasing since the second derivative is positive when h is 3 feet. How do we feel? You didn't like it at all? All right, tell me where you're confused. Because they wanted to know if dHdt was increasing or decreasing. So look, okay, throw it away. How do I know if f is increasing or decreasing? Yeah, I'm not in this problem anymore. I'm just asking a general question. How do I know if I have a function called f, how do I know if f is increasing? Yeah, if the derivative is positive, f is going up, right? If the derivative is negative, f is going down? Do you agree? F is decreasing? Okay, now let's go to this story. How do I know when dHdt is increasing? When the derivative of dHdt is positive. Well, what's the derivative of dHdt? The second derivative, d squared h over dt squared. Does that make sense? So where is dHdt increasing? When the second derivative is positive. Where is dHdt decreasing? Where the second derivative is negative. Cool?
Okay. Well, like, looking at the question, I would have not thought to do that because like how would you know, like, oh,
No, well, that's why it's a play on words. You got to read it carefully. Look, see how I put a bracket, the rate of change of the height of the water with respect to time, and then I ended the bracket? All that in blue is dHdt. Like you should know, like that we should know. So then you can just say, okay, pretend that literature is not there, and let's fill it in with dHdt. And then you read it again. When the height of the water is 3 feet, is dHdt increasing or decreasing? Oh, they want to know where dHdt is going up, or is it increasing or is it decreasing? That makes sense? Yeah. So you just, like, you put that in bracket and you're like, oh, and then you just delete it. Pretend you delete it. And then like, all that means dHdt, and then you read it. When the height of the water is 3 feet, is dHdt increasing or decreasing? Oh, okay. I need to figure out the derivative of that one. Cool? Any other questions, guys? Ask. dHdt is negative.
What is that?
Oh, it just means that my height of a water is, the water height is going down, but it's decreasing at an increasing rate. Yeah, don't worry. Yeah, then, well, it would have been easier if it would have been increasing. Like, okay, increasing at an increasing rate, increasing at a decreasing rate. I think it's always easier to look at that. Do we know what both of those mean? So it just means like something, you know what, I actually saw a Facebook article about this exact, for the ocean, something increasing at a decreasing rate. So when I say something is increasing at an increasing rate, I mean that I'm like exploding. When I say something is increasing at a decreasing rate, it's growing, but not fast, not as fast. I'm trying to look for a marker here. It's kind of similar to your concavity thing. Okay, I'm not in this situation because this one, the dHdt was negative. Increasing at an increasing rate. So this is my original, and I know it's hard to see. That's increasing at an increasing rate. All my slopes, they're getting faster and faster. Increasing at a decreasing rate looks like this. I'm still increasing, but it's slowing down. The rate of change is slowing. That makes sense? So that's what they're, kind of trying to say here. So if you're trying to see like, well, what does it mean? Because you're like, what does that mean? That's... Yeah, well, dHdt is negative, but they don't want to know. They want to know, is dHdt increasing or decreasing? So they want to know, like, oh, it's positive, so you're decreasing it. Okay, all right, here we go. Yeah. Oh, because I took the derivative with respect to time. The derivative of h with respect to time is dHdt. If I would have taken the derivative of h with respect to h, then I would have left it alone, and I would not have a dHdt here. But I didn't take the derivative of h with respect to h. I took it with respect to time. That makes sense? That's going to come in super handy when you take multivariable calculus at MIT. All right, here we go. Last one. At time t equals 0, and I know that I just put you guys on the spot. The height of the water is 5 feet. Use separation of variables to find an expression of h in terms of t. Do you guys want to lead me on this one? So they want, what do they want? An expression of h in terms of t. They want h of t, right? Okay, so tell me, what do they give me? What was dHdt? Okay, what's the first step? Move the h's with the h's, move the t's with the t's. There is no t. Well, you're going to leave the constant there then. So how do I get rid of that square root of h to go to the left? Divide. So dh over square root of h equals negative 1/10 dt. Can everyone do that? I'm going to rewrite it so it's simpler. Here we go. I'm rewriting it, guys. I haven't taken the integral yet. I'm going to write h to the negative half dh equals negative 1/10 dt. Are we still okay? Now I'm going to what? Integrate. So here we go. I'm going to have, so h to the negative half, add 1, divide by that number. So negative half plus 1 is a half, and then when I divide by half, that's the same thing as multiplying by 2. So there it is, 2h to the half equals what? Negative, and then what letter do I use? t. And then I put, what do I put? Plus c. Can everyone get to there? All right, next. Do they tell me, look what they tell me, at t equals 0, how much water do I have? Yes. Yes, I just did my power rule, or the opposite of power rule. So that negative half, I added 1. So that's where I got a half. And then I divided by a half, which is the same thing as multiplying by 2. Okay. Are we still okay, guys? All right, here we go. I know this much. When h is 0, water is 5. When h is 0. When time is 0, water is 5. So h is 5. So that's what I'm going to plug in. Are we okay? So I'm going to go 2 square root of 5. Does everyone okay with why I wrote square root there? H to the half is square root, right? Okay, you know what? Let me rewrite it. 2 square root of h equals negative 1/10 t plus c. Okay, now we're good. 2 square root of 5 equals negative 1/10 times 0 plus c. So what does that tell me about c? C is 2 square root of 5. All right, so here we go. I'm going to rewrite it. 2 square root of h equals negative 1/10 t plus 2 square root of 5. All right, what am I trying to solve for? H. So how do I get rid of the 2? Divide by 2, divide by 2, divide by 2. So now I have this. I have square root of h equals negative 1/20th, just put the 2 next to the 10. 1/20th t plus square root of 5. Now how do I get rid of the square root? Squared. 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 Oh, man. Squared. Let me zoom in on that. There we go. So here's my equation. H equals, and I'm not going to expand it, leave it alone. This is your answer. It's going to probably, all of them are, the rubric's probably going to have this answer because it's the simplest one. And if you want to write h of t, go ahead, but you don't have to. I think they would still give you the credit even if you just wrote h. How do we feel? Well, we know it's a function of t, but you could have just written, if you just did that, you're fine. Oh, well, this is simplified. I mean, you could expand it, but this is this is the best. You know what I mean? That's my equation. That's what they wanted right here. No, you don't. You can just write h equals. Should we look at the rubric? Look at the rubric. I was looking at it earlier, but I didn't look at it good enough. All right, let's see. Number 4, letter A. Yeah, I think we did it exactly the way they did it. They put the fancy little line with the h equals 4 in the bottom. That just means evaluated at. How many points was letter A? 2. Look, they give you 1 point for the unit. So even if you didn't know how to do the derivative, if you know, it's cubic feet per minute, cubic feet per second. If you wrote cubic feet per second, they probably, maybe, I don't know, but it says there 1 point for the answer. I wasn't there to grade this one, so I don't know if it's a condition or not. Sometimes it is. Letter B, how many points? Did we get it right? 1/200, because the second derivative is positive. For h greater the rate of change, the height of the increase in the water is 3 feet. Yep, perfect. We got it. All 3 points. Letter C. Notice that they give you a point for separating them. So that means the h's with the h's, the t's with the t's. You see that top line, that first line? That's 1 point. Isn't that cool? Antiderivative. If you take the antiderivative correctly, that's 1 point. Let's see, constant of integration and uses initial condition. That means the c and using the 0 and the square root of 5. That's another point. And check it out. let's say you didn't know how to get H of T, relax. H of T is only worth 1 point. So all the work leading to H of T, maybe you thought, man, I don't know if I can do that. Well, it's only worth 1 point. So if you get 8 out of the 9, you're probably in pretty good shape. Did we get their equation? Yeah. Notice the little note. What does it say? You guys want to read it out loud? Look at the both notes. Look at the top note. How many points out of 4 if you don't separate? 0. That's because a lot of kids are doing the antiderivative immediately because they can see it. Don't blame them. Their teacher hasn't told them. They can see it and they're smart enough. Like, oh yeah. So they go right from the equation, from the first line here, right to this, because they can see it. They're like, oh yeah, antiderivative and blah blah blah. But because their teacher didn't tell them, like, hey, that's a point. 0 points if you don't separate. Cool or not cool? So how do you feel? Okay, so don't worry. We're going to start off simple. You have a delta math. We're not going to give you word problems just yet. All you're doing is practicing doing antiderivative and getting your initial condition. Separating your variables. Does that make sense, guys? So we'll finish the rest tomorrow. Make sure you practice. So let's do our delta math, guys.
So I wasn't here for yesterday because of the ACT.
Read this right here, law of exponential change. Read this whole paragraph. So all this time that you've seen the formula PERT or all that good stuff, it comes from this. For those of you that are into financing and know about your formula, 1 plus the rate divided by how often it's compounded, raised to the time, it comes from this. How much money how fast your money grows depends on how much money you have in your bank. The more money you have in your bank, the more interest, the more money, the faster it grows. So if you get a chance in this world to accumulate a lot of wealth, yeah, I mean, let the money work for you, and then it just works for itself. The more money you have in there, the more you get. Isn't that cool? Okay, so invest. So as soon as you get a chance, start investing. We're going to derive this formula. You do not have to derive it over and over again. You've probably seen it. It's this one here. You probably saw it in chemistry, maybe when you were working with half-lives or something. You've seen it for sure in algebra. Do you remember PERT? I think it's the initial amount invested, E raised to the rate times time. It comes from this. It's the same formula, except we call it y naught e to the kt. So we're going to derive that. You don't have to derive it every time, guys. As soon as they tell you this, you can immediately write a general exponential equation. Cool? Okay, so here's how we derive it. dy dt, so you guys follow along, equals, ky. And what I want to do is solve for y. So I'm going to group the y's with the y's, and in that case, just a constant, right? So I'm going to write it like this. I'm going to write dy over y equals, I'm multiplied by dt, so I'm going to write k dt. Are we still okay? Okay, I'm going to rewrite it so it's nice for you guys. 1 over y dy equals k dt. And now I'm going to integrate. So now this on the left-hand side, 1 over y dy, I'm going to have absolute value of y equals kt plus c. Oh, I'm dummy. ln. ln, absolute value of y. I don't know why I did that. I did get plenty of sleep. At least I think I did. Okay, you guys ready from here? Oh, I'm integrating this with respect to t. So k is a constant. K just put, yeah, k is a constant. Are we okay so far? I don't want an ln. I just want a general expression. So I'm going to put e and E. And I'm going to move it up here. So I still have absolute value of y equals e to the kt plus c. Are we still okay? Then your laws of exponents come into play. And I can do absolute value of y equals e to the kt times e to the c. Are we still okay at the moment? Have I confused anyone? Okay. I just did law of exponents, guys. This is all an exponent up here, so e to the kt times e to the c is the same thing, right? Because then you just add your exponents. Okay. I'm separating it for a specific reason because I want it to look like this, and you're going to see it in a little bit. You're always going to separate it. Okay. I want to figure out a general expression. I don't want this absolute value. You're going to let the situation dictate whether what your constant is. So notice that I'm not writing a y and absolute value anymore, and I'm writing a big C e to the kt. Don't worry, I know you guys have questions. This e to the c is just some constant. So that's what that c now is. And the absolute value is absorbed with the c because the situation will tell me whether y is positive or y is negative. Does that make sense? Yeah, the book, I don't agree with the book. The book has an intermediate step in the middle. The book has this step. It says y equals plus minus e to the c, e to the kt. And then they just say, this is just some constant. Maybe you like that better. That is just some constant. And then they write this step, y equals c, e to the kt. Maybe you like that better. I don't know. The plus minus came from the absolute value, right? The definition of absolute value. I prefer not to write this step here and then just say bam and then let the situation tell you whether it's positive or negative. Yes. It didn't. It's a constant. E to the c is a constant. It's a new c. It's not this c. E to the c is just some constant.
Oh, that's right.
Yeah, that's why it's big. It didn't come down. Well, because it's a constant. Like it can be anything. I just made it look pretty. So if I have any constant, regardless of how it looks like, e to the blah 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 blah, I just made it into a constant. Now if I had a variable up there like an x, then I couldn't do that, right? Do you know what I mean, Castillo, or no? Do we have any questions, guys? Hit me. Notice that equation, and yes, I know it says we're going to figure out if k is positive, it's a growth. If k is negative, it's a decay. I just let the situation tell me what my k is, and I'll solve for my k on my own terms, and then that will decide whether it's positive or negative. I don't do, because you can do the thinking and be like, oh, it's going to be positive, and then force stuff, but then just let the numbers figure themselves out. Do you know what I mean, guys? You don't have to do, okay, so here we go. Look at all this stuff here. Now we're getting into chemistry world. Should we read this together? Yeah, let's read it together. Don't worry, we're going to use this, and we're going to show you that you don't have to do this base. You don't have to do E all the time. You can choose a base, and it'll still get the same answer, but you'll see what when we get there. When an atom emits some of its mass as radiation, the remainder of the atom reforms to make an atom of some new element. This process of radiation is a change in radioactive decay, and an element whose atoms go spontaneously through this process is radioactive. Radioactive carbon-14 decays into nitrogen. Radium, through a number of intervening radioactive steps, decays into lead. Experiments have shown that at any given time, the rate at which radioactive element decays, as measured by the number of nuclei that change per unit of time, is approximately proportional to the number of radioactive nuclei present. That is this. Thus, the decay of radioactive elements is described by the equation blah, 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 dy dt equals negative ky. So if y naught is the number of radioactive nuclei present at time 0, the number still present any time later is going to be this equation. The half-life of radioactive elements is the time required for half the radioactive nuclei present in the sample to decay. Example 7 shows the surprising fact that the half-life is a constant that depends only on the radioactive substance and not on the number of radioactive nuclei present in the sample. So you can see this comes out all the time in science and math and money. This equation comes out all the time. And don't worry, guys. We're gonna be as easy as possible. We're gonna make this as easy as possible. We're gonna be frank. I don't know why I said that. Okay. Find the half-life of a radioactive substance with decay equation y equals y naught e to the negative kt, and show that the half-life depends only on k. I guess. So they want to see an equation for half-life that depends only on the k. So we're gonna see k times something. K over ln of 2, I think, is the most common or whatever. So we're gonna find out. So I'm gonna write half of y naught equals y naught e to the negative kt. Are we okay with that? Oh. Do we understand the equation? No? All right, let's start. Let me erase. All right, what is the question asking?
I don't know what half-life means.
Half-life, you guys have had chemistry, no?
Yeah, we usually
Oh man, I feel a lot of hostility. All right, guys. Let's talk about what half-life means. Half-life means the amount of time for half the substance to remain. That's what half-life means. It's a topic covered in chemistry. It's definitely a TEK. I know 100% because I remember doing it in high school, and then I remember doing it again at the university. So, and then I think maybe even in physics too. The word half-life does not ring a bell, maybe? No? Okay. So what they want, so here's the question that they're asked. It's okay. It says, find the half-life of a radioactive substance with decay equation. So they're telling me that I have this decay equation. And show that the half-life depends only on K. So half-life means how long does it take for me to have half of it? Does that make sense?
So if it's decay, how long does it take?
How long does it decay?
From full to half?
Yes. So if I were to tell you something like, I don't know, pretend I have a bucket of water with 5 gallons, and I open the bottom, and I say, find my half-life. That means how long does this bucket of water take to get to half of 5, which is 2.5 gallons. Does that make sense? And you're going to see this over and over again in chemistry, anytime you're doing with radioactive substances, and definitely, so probably physics as well. So that's half-life. Is this the first time you've heard of this? Okay, I'm sorry, guys. I didn't know that. I thought this was something that we've done in the past. Okay, so all it means is how long did it take for for you to get half of something. Cool? So here's my equation. And that y naught, hopefully we have enough experience. That y naught there means the amount initially present. Cool? So what I'm going to do is I'm going to write, if this is the amount initial, and I want half of that, I'm going to write half of that amount. Do you guys see what I wrote there? Equals, and then I write this side. The initial amount, e to the negative kt, and this is supposed to be my half-life, so I'm going to put a subscript of a half.
Okay, so the reason you substituted the 1/2 y naught for the y is just whatever you're looking for.
The y, yes. So this is the initial amount, and I want half of that. And what they want me to do is solve for t. And when I get my t equation, it doesn't matter how much you have. They want me to see that I have a k times a constant, or divided by a constant. Does that make sense? What's up? Yes. I don't have to. I don't have to put half of the subscript, but I put half of the subscript because this is going to be my half-life. This is how long it's going to take for me to have half of this. Yes. I don't have to put a half in the subscript, but I did because this is the time that it's going to take for me to get half of it. Yes. So whatever time I get, that's my half-life. That's how long it takes for me to have half of something. Cool, guys? Okay. I'm going to solve for t. So the first thing that goes away is the y naughts. Do you guys see that? So now I have 1/2 equals e to the negative kt t, and I have a subscript of half. How do I bring the negative kt to the half down? It's an exponent. I think I heard someone say it, but maybe you didn't say it loud enough. ln, yeah. ln degeneres. So now I have ln a half equals negative kt to the half. Are we still okay? How do I get t by itself? Divide by the negative k. So here's my formula. Now, maybe chemistry books don't have this formula written like this. And let me show you a better formula. And maybe we'll Google it in a little bit. And you'll see the formula so you can see. I don't know. I've never tried it, so we'll find it right now. Do you guys know that ln of a half is the same thing as ln of 1 minus ln of 2? Okay. Well, what's ln of 1? 0. So I really have my half-life formula is negative ln of 2 divided by negative k. What's negative divided by negative? So my formula for my half-life just depends on k. There's a k in there. That's all it depends on. And I'm going to see if this is true I'm going to go to Google. And I'm just going to type in there calculating half-life for radioactive substance. So let's see if we find that formula. You guys ready for this? All right. Let's see if we find that formula. I type better with the keyboard, but I don't know if my keyboard will work. Let's see. Will my keyboard work? No. What if it doesn't work? I'm gonna have to type it out a long way. It's because I don't wanna unplug it because it's recording. You know what? I'll just do it with my phone and I'll just show you guys. What was I gonna do? Half-life.
Okay, give me your lunchbox. No, I don't think. No. You're missing a lot, but it's not like we're not gonna grow this gap now.
Look at that. I bet you. Look. Sorry. All I did was I Googled radioactive. Let me tell you what I put. I already forgot it. But it was like the first link for half-life. And I want to show you, I'll pass it on. It says my half-life formula is 0.693 divided by lambda, where lambda is given. Lambda's like that K. I bet you $100. I'm not a gambling person, but I bet you $100 that 0.693 is ln2. You want to see? All right. ln2. Watch it be wrong, right? Look at that. And I just did a basic Google, and I just found it where half-life of that isotope was 0.693 divided by K. So when you get to your chemistry class, your organic chem or your chem, and they're like, oh, your half-life formula is 0.693 divided by lambda, find your lambda. There it is, guys. Cool, right?
So wait, all we're doing was deriving the equation?
All we're doing was deriving the equation. I'll take my phone, because it's my house phone. I promise you, I don't mind you guys having my phone. I have nothing to hide. But this is my hotspot, and the further away it is, like, you know what I mean? Like, then this disconnects, and then I have to reboot, and then I should have done it with my other phone, but it's not my hotspot. I'm sorry, guys. But trust me, you Google it. Whenever you get a chance, put half-life of isotopes, blah, blah, and you're going to see. Okay.
So that's the equation for the amount of time it takes any radioactive substance.
Yes. Yep. All you need is a lambda or a K value.
K will depend on the substance.
K will depend on the substance.
That's so cool. Okay.
All right. Now here it is. We're going to do this question two ways. Well, hopefully, if we're smart enough, we'll do it two ways. It says, ready guys for the next example? Is this the last one? Oh, two. We got two more. Yeah, no problem. We're good. It says, choosing a base. At the beginning of the summer, the population of a hive of bald-faced hornets, which are actually wasps. Did you guys know that? Well, now you know. Bald-faced hornets are wasps. Is growing at a rate proportional to the population. Okay, underline this right here. So that means dy dt equals ky. It's growing at a rate proportional to the population. From a population of 10 on May 1st, because dy dt is growth, and y is the amount present, and then k is just some constant. So your growth is growing proportional to how much you have. From a population of 10 on May 1st, the number of hornets grows to 50 in 30 days. Okay, so what do I have? T equals 30 days. And I went from initial population of 10 to final population of 50. I'm just writing stuff down. I could have put P of 30. That's fine. You know what? I like P of 30 better, because that says P of 0. If the growth continues to follow the same model, how many days after May 1st will the population reach 100? Okay, you guys ready for this? My population, unless you want to start from scratch, but I wouldn't. dp dt and letter P, replace the P instead of Y. So my population is equal to some constant times some base raised to the time kt. We're going to figure this out, guys. And don't worry, in a little bit I'll show you how to be a robot if you want to be a robot. Yeah, you'll see. Okay. I went from 10 to 50, so I already know what my initial constant should be. It should be 10. 10 times what number will give me 50? So my base is a 5. Do you see how I got that? Okay, now what is your k? Well, it took 30 days for me to get to grow by 5, so my k needs to be 1 over 30. So k, 1 over 30. Does that make sense to you guys?
I don't understand how we're getting these numbers.
Okay. Because I know that the amount of hornets grow proportionally, I know that I have an exponential function. It doesn't matter how I look. I can be, I have some constant times some base and then raised to some power. And it's always going to look like that. So I got all these numbers from what they gave me. They told me that my initial population was 10. So that's how I got this number, 10.
Because that constant will always be your initial.
Correct. And then how did I get the 5? Well, I went from 10 to 50. So 10 times what number gives me 50?
Why is that the process that you use to solve that?
Oh, because it's the easiest for me. I said, well, 10 times what is 50? I know it's an exponential. This is all the information I have. So I want to have an exponential, but when I plug in a 30, I want to get a 50 out.
Because those two numbers, 10 and 5, have to include your final?
Well, when I plug in a 30, I better get an output of 50. And I know that it needs to be an exponential. Don't worry, I'll show you a different way in a little bit that maybe you'll like better. I've had a lot of students say, I'm not going to do that ever again. I'm just going to always use my general equation and solve for k with a calculator. I'm going to show you a different, maybe I should have done that first, I don't know. But do you agree that if I plug in a 30 for time, that I get a population of 50? Yeah, 1/30 times 30 is 1. 5 to the power of 1 is 5. 10 times 5 is 50. So it works. Do you guys see that? It works. They want to know, when will this population reach 100? And we're going to see if don't worry, do you see why the equation works though?
I see why it works. I don't see how it would.
Oh, you just, okay. You know it's an exponential equation. Your exponential equation is always going to look like a constant times the base raised to a kt. Always. So how would you have come up with that? You said, okay, well, my initial was 10, so that solves that. The only thing you have is this. The population was 50 in 30 days, right? So you said, okay, how do I get a 50 if this is 10? Well, the only way to get a 50 if that's 10 is to multiply by 5. So then you said, okay, my base better be 5. And then you say, okay, well, it happened in 30 days, so I'm going to put a 30 here. And then I want to get this to be a 1, so k has to be 1 over 30.
Oh.
Do you see how we did it one step at a time?
Okay, that makes sense.
Okay, you just got to go slow.
Yeah.
Okay. Don't worry, guys. I'm recording this so you can go back to it and you can see how we did it. Are we okay so far? Check it out. You guys ready? It works. It worked at 0 and it worked at 30. So this is my equation. They want to know how long it takes for me to reach a population of what? So I'm going to write 100 equals 10 times 5, 1 over 30th times t. If you look at a textbook, they might write it as t over 30. I don't like that. I want to see the k value. Are we okay? And check it out. Okay, well, okay, we're good. I want to solve for t. What is the first thing I do? Divide by 10. Divide by 10. Divide by 10. So 100 divided by 10 is 10 equals 5 to the 1 over 30th times t. Tell me what I should do next. I want to bring that 1 over 30th t down. So to do that, I need to put a what? ln. Whatever you do to one side, you got to do to the other. So now I have ln of 10 equals 1 over 30th times t ln of 5. And now it just becomes algebra. Well, all of it has been algebra so far. What do I do next? Divide by... Okay, let's take it one step at a time. ln of 5. Perfect. So now I have ln of 10 divided by ln of 5. No, don't try to do ln of 2 because that's not the same. It's ln of 10 minus ln of 5, that's ln of 2. Equals 1 over 30th times t. How do I get the t by itself? Times 30, whatever you do to one side, you do to the other. That's a 30 there. So t equals 30 ln of 10 over ln of 5. Let's see what that is. Take your calculator. I'm going to go 30 ln of what? And then divided by ln of, and I get that time. And let's write all the digits because I want to test something. 42.9202964, okay. 42.920, give me all of the digits, guys. 29674. And there it is. Now let's say you, okay, so don't write this down, just listen. In a little bit, I'll let you write all you want. Let's say you're like, Chavez, that is way too hard. You made me think too hard. I have to think about a base. I have to think about what is what. Don't way too hard. Okay, you can let the situation dictate what the equation is going to look like. You could have said this. The amount is depending on this. Right? You could have said this. And you could have done, don't write this down, just listen. This, you know that initial amount. What is that initial amount? 10. So you just go, you put a 10. And I'm like, Chavez, I'm going to solve for k because this is all I know. And why do we know this? Because we know this part. The dy dt equals ky, so I can use this equation. Does that make sense? So check it out. I'm going to put a 50 on the other side. What am I doing? I'm solving for k. 50 equals 10 e to the 30k. Are we okay? All I did was plug in t equals 30 and plug in my population at 30 days. Is anyone confused? Okay, I'm going to solve for k. Divide by 10, divide by 10. What's 50 divided by 10? 5 equals e to the 30k. Now, how do I get the 30k down? ln. So I have ln of 5 equals 30k ln of e. But remember, ln of e is just 1. That's why I didn't write it last time, sorry. And then so I have 30k equals ln of 5. How do I get k by itself? Now, it's going to be a small number. Now, check it out, guys. K equals ln of 5 divided by 30. I'm going to type it into the calculator. I'm going to store it into memory. So I'm going to write, and don't write this down, just listen. In a little bit, I'll let you write. What did I have? I already forgot. Short-term memory. ln of 5 divided by 30. enter, and I'm going to store that into alpha k. So do you guys see that I'm storing that into alpha k? Okay, now check this out. I hope we did everything perfect. I'm going to write y, the population, equals 10e to the kt, where this k is this k. Are we still okay? I want to know how long it takes for this population to reach what? 100. So let me write this in blue to indicate that I already have the k value stored. Now check this out. Look how beautiful this is. Watch it not work, right? It's gonna work. I'm gonna divide by 10. I'm still solving for t. Divide by 10. 100 divided by 10 is 10 e. So 10 equals e to the kt. What am I doing? Solving for t. So now what am I gonna put to bring the kt down? ln. So ln of 10 equals kt. Now remember, I already know that k value. It's in my calculator. How do I get t by itself? Divide by k. So technically, what I'm trying to tell you is that if you were to do it this way, do you think I will get the same answer? It better be. If I don't get the same answer, I'm a fake, and I don't want to be a fake. So let's see. ln of 10. Here's the moment of truth. I'm a little nervous. I didn't try it before class started. Divided by, oh, I didn't push division. Sorry guys, hold on. How do I get rid of that? Let's do it again. ln of 10. See, I'm nervous, guys. Divided by alpha k. Here's the moment of truth. Look at that. Did you get the same answer? So, and I've had kids tell me this before, and they were successful. Here's what they told me. Mark Cruz, I'll never forget him. Chavez, that's too much for me. If I see that it's proportional to the population, I'm just going to always write, bam. And I'm just going to solve for k. Once you solve for k, whatever they want, I'm going to solve for time. And that's what he did for the UH quiz of population. He was like, I'm not going to bother writing a general, I'm just going to do this one. Like, all right, fine, whatever. And it works. Cool or not cool? But you don't have to use E, you can use any base if they give you numbers that are nice. How do we feel? All right, now you can write stuff down if you want to write down stuff. Should I leave it right there for a little bit? Okay. I wonder where Mr. Cruz is at. Now you guys learned some chemistry today and some population, so maybe now you can do biology half-life stuff. For those of you that are in AP Bio, have you guys done a half-life in AP Bio? No? AP Environmental Science, half-life? So now you know where the formula comes from. So next time you have environmental science with Wentz, I know where this half-life formula comes. I can get it. I can derive it for you, Wentz, and you can derive it. I think we got one more question. I don't remember it. All right. I always get confused when doing some questions like this. This is just like a typical physics question or chemistry question. Um, so it always confuses me, like when I write it. You'll see what I mean. It says, scientists who use carbon-14 dating use 5,700 years for its half-life. Find the age of the sample in which 10% of the radioactive nuclei originally present have decayed. Okay, if 10% have decayed, that means I have 90%. So then I should write 0.9 of y naught equals y naught e to the kt. If you remember your half-life formula, which I already forgot it, you see, like I already forgot it. I think it was like ln of 2 divided by lambda, so ln of 2 divided by k. So I could use it, but let's pretend that I don't know it. So then I'm going to solve for k, just like I did a little while ago. So you know what? I'm not going to solve for time just yet. I'm going to solve for my k. So I'm going to say, if you forget, formula for t half, just get k. And I'll show you how to do it both ways. Just get k with situation. All right, how do I get the k? Like this. All right, half y naught equals y naught e to the 5700 k. Does everyone know why I used that? They told me that it takes 5,700 years for carbon-14 to get half of its nuclei left. Oh, right now I'm just solving for k. I'm getting a k. For specifically, yeah. And you can probably look it up. In chemistry, obviously, according to that website, they call it lambda. It's, whatever. All right, you guys ready? The y naughts cancel out. 1/2 equals e to the 5700k. How do I bring that down? ln. So ln of 1/2 equals 5700k ln e, but ln e is 1. And then I'm going to go ahead and leave it as ln half. I know that you can write negative ln 2. All I got to do is divide by 5700, and that's my k value. Leave it in your calculator. It's going to be a small number because the half-life is so big. So I'm going to write, I already forgot, ln of 1/2, ln of 0.5, divided by what? 5700. So there it is. Negative 1.21 times 10 to the negative 4. Are you shocked that it's negative? No, it's decaying. You see, you let the problem tell you what it's going to be, positive or negative. Store alpha k. So in my calculator, it says k. Cool? So now I come back. What was it? Negative 1. Yeah, at least, well, I would write one more digit at the 216. There we go. I would write one more digit. 10 to negative 4. All right, so here we go. They want to know how long it takes for me to have 90% of it left. Because they said 10% decays by 10%, right? So 0.9 y naught equals y naught e to the kt, where this k is this one. Does that make sense, guys? And I'm going to start writing it in blue to indicate that I already know what k is. 0.9, the y naughts cancel out, equals e to the kt. What do I do next? ln. So now I have ln of 0.9 equals kt. And now what do I do? Divide by k. So t equals ln of 0.9 divided by k. I don't know why that took long. So here we go. ln 0.9 divided by alpha k. 866.417 years.
So that is how long it took?
Yes.
From starting to get to 90%.
Yes.
Okay.
Yes. And that's how scientists use carbon-14 to date dinosaurs and all that stuff, guys. Isn't that cool? Or you guys are like, oh, I'm not impressed.
No, that is really funny.
What's up, miss?
Did I do a cost of that?
I don't. Oh.
Yeah. Thanks.
All right. Let's see if we could have figured it out with this formula here. Okay. This formula just would have given us the k value really quick. So k equals ln of 2 divided by your half-life. So ln of 2 divided by, that's what we did, ln of 0.5. But remember, see, the reason why I don't trust this, because then you got to think, is it positive or is it negative? This is going to give you a positive number. But then you got to think like, oh, I'm decaying, so I got to put a negative in the front. Does that make sense? So that's why I don't even trust this. Don't trust formulas, just derive it. Does that make sense, guys? How do you feel? Yeah, we're going to get a practice.
I understand how you were doing it. I just don't know if I can do it.
Okay. So there is going to be a practice. I just didn't type it out. So how about, plus I don't think we have enough time to really practice it. So how about you just finish everything up? There is a new UH quiz anyways that does not require this. It's called area. It's the one right next to average value. Have you guys already done that one or no? Yeah, that's, what's the number on that one? It's right next to average value. 28, so 29. Can you guys take care of UH quiz 29?
Did you have a video of the 26?
Not for 26.
Or